This problem and all other practice problems for Calc 2 here at Rutgers can be found in Sarai Studies. A link is in the description box below. Does the following series converge or diverge? Because we are in the DCT section, so the direct comparison test, we will be using the direct comparison test. But if this were a random question on an exam, how would you know to use a direct comparison test? I'll answer that question at the end of the video. But let's go ahead and get started. So I always write the rule for whatever test I'm using. If you haven't watched the video I made before this, which shows you how to not memorize the rule and just derive it, go ahead and do that. But this is the rule. If the sequence A of n is less than or equal to B of n, and the series B of n converges, then the series A of n will also have to converge as well. And then you just take the opposite signs here. Remember, these rules take into account that A of n is always your given sequence, and B of n is the one that you will have to come up with, and I'll show you what I mean in a second. So DCT is really just 5 simple steps, and I remember it as I, B, B, C, C. So I stands for information. So this is the information that we know plus the information that we need. So right now we know that our given sequence A of n is 1 over n times 3 to the n. What we need, because we don't know right now, is what our B of n is. So that brings us to our second step, which is B, literally find B of n. So how do we do that? To find B of n, you literally take your given sequence A of n, and you say at large n, this becomes what? So essentially, as n gets so big, what becomes insignificant here? Well, this n becomes insignificant. So this really becomes 1 over 3 to the n, because this 3 to the n overpowers. I mean, you can check. If you have 3 squared and then just 2, right, n would be 2. 3 squared is 9, and this is 2, so this is going to overpower. This will always be bigger. So as n goes to infinity, this really becomes insignificant because this will always overpower. So this is our B of n, so we're going to go ahead and plug that right in here. So essentially, this step is literally just taking your given sequence and crossing out anything that becomes insignificant when n gets really big. This brings us to our third step, which is another B, but this time this B stands for the behavior of the series. So we have the series from n is equal to 1 to infinity. By the way, where do I get this from? I get it from the original problem. So if this says n is equal to 1, then I put n is equal to 1 to any series that I write. B of n is 1 over 3 to the n. In this step, you will always use either the p-test or the geometric test. In this case, I see that I can rewrite this as 1 over 3 to the n, because if I distribute the n, this becomes 1 to the n. 1 to the anything is just 1, and then 3 to the n, so it becomes the exact same thing. So I can rewrite it in this form, and I know that my r is equal to 1/3, because whatever's on the inside is your r. So the way that I remember the geometric test is, personally, I like calc better than geometry, so I think geometry is less than calc, and so then 1, and then what we care about is the absolute value of r, converges, and then we have the opposite is true. And so in this case, the absolute value of r is equal to still 1/3, which we know is less than 1 because you have 1 and it's being divided into smaller pieces. So therefore, this series converges. So by the geometric test, where the absolute value of r is equal to 1/3, which is less than 1, the series B of n converges, meaning that this condition right here is met. Now, if this is met, we hope that this is true, because if this is true and this is true, then this is true. We could say that the series A of n, our given series, converges, which brings us to our fourth step, which is the comparison step. We compare A of n and B of n, and we hope that it's less than or equal to in this case, because this is already true. So we're comparing A of n and B of n. So I'm going to take A of n, and I'm going to take B of n. I'm going to put a circle right in the middle, and I'm going to compare the two. I notice that the numerators are the same, so all you're really doing is comparing the denominators. This one is obviously bigger than this denominator, because this one has an n being multiplied to the 3 to the n. And so because this denominator is bigger, then that makes this whole fraction smaller than this fraction. And so therefore, A of n is less than or equal to B of n. So we've met this condition over here. And so now, because we know that this is true and this is true, now we can say that the series A of n, our given series, converges. Which brings us to our last step, which is C for conclusion, where we put everything together in a nice sentence. So I always start with since, so since, and I follow the format of my work, so blue and then green. So since the series from n is equal to 1 to infinity of 1 over 3 to the n, so B of n, converges, by the geometric test, where the absolute value of r is equal to 1/3, which is less than 1. So that's this blue part right here. And then the green part, but I actually have to write what a of n and b of n are, which I did, so that goes in here. Technically speaking, there's a 0 here because DCT and LCT, these comparison tests, only work with series with positive terms, so terms that are greater than or equal to 0. And we say this is true for all n greater than or equal to whatever is in your problem here. So if this is 1, then you put 1 in here. So that's the green part. Then we say, comma, DCT implies, the direct comparison test implies that the given series from n is equal to 1 to infinity, 1 over n times 3 to the n, will also have to converge as well. That's the yellow part over here. So this is your answer and this is your justification. So make sure you have your 3 parts from the rule. Green, blue, yellow. Now I promised I would explain if this were a random question on an exam, how would I know to use DCT? Well, after you do a lot of these problems, you'll be able to get to this step in your head. So in a test, if I see this, immediately I ask myself, is there any way I can cross out anything, make this even more simplified? If no, then there's no way that I can find a sequence that I can compare to, because essentially what we're doing is taking a of n. So if I can't see anything that might cancel out, I'm not even going to try doing DCT, because DCT needs a B of n, and also LCT as well, which we will get to in the next video. Because, by the way, DCT and LCT, they both have the same 2 steps. So like you need to have a B of n in both of these comparison tests, because a comparison test, you need something to compare to. So if you can't find a B of n, you have nothing to compare with. So you can't do or use the comparison test. So do more of these problems and you'll find that you can do this step in your head. And if you can't, then that means you will not be able to do DCT and LCT, and you'll try another test, which you will learn in the future. Hopefully you found this video helpful, and I'll see you in the next.